Chapter 2, Section 1. After you read the objectives, you can go ahead and do problem number 1. So here you're solving the system of equations by graphing. So the graph is given, so let's look at the first equation, y equals 4x plus 7. So here you start at your y-intercept at 7, and you would normally go up 4 and over 1, but there's not enough room in the graph, so here we fall 4. So here we fall 4, 1, 2, 3, 4, and to the left 1, and this is the equation y equals 4x plus 7. And then the other equation, you would start at your y-intercept, so you start at 1, and then you would fall 2 because it's negative, so you go down 2 and run 1. And this is the second line, negative 2x plus 1. Seeing the solution where they intersect, x is negative 1 and y is 3. And that is your point of intersection, negative 1, 3. Problem number 2. Again, solve the system of equations by graphing. So you would do the same thing. For the first line, y equals negative 5x plus 5, you start at 5, which is your y-intercept. And then you would go down 5, so 1, 2, 3, 4, 5, and to the right 1. So this is this line, y equals negative 5x plus 5. And the second equation, you start at negative 2, and then you rise 2 and run 1. So start at negative 2, and then you go up 2 and to the right 1, and this is the equation y equals 2x minus 2. And the solution is the point of intersection, which is 1, 0. So your point of intersection is x equals 1 and y equals 0. Let's move on to problem number 3. Problem number 3, you solve the system of equations by the algebraic method. And here I will choose the elimination method, which is called the addition method. So using the addition method means I want to cancel one of my variables, and here I want to cancel the x. So to cancel the x term, I want to multiply that first equation by negative 2. So multiplying all terms by negative 2, I have negative 4x minus 2y is equal to 20. And I'm going to add it to the second equation, 4x plus 3y equals negative 14. And we see that the x term is canceled. Now we combine the y. Negative 2y plus 3y is just 1y. 20 minus 14 is 6. So once we solve for y, we substitute this 6 back into either equation, and I'm going to substitute it into the second equation. So I have 4x plus 3y equals negative 14. So 4x plus 3 times 6 is equal to negative 14. And solving for x, I have x is equal to negative 8. And this is my solution, negative 8 and 6. Problem number 4, solve the system of equations by an algebraic method. And here I am going to use the substitution method to solve this equation. So I'm going to substitute this first equation into my second equation where the y is. So I have negative 3x minus 13 is equal to 5y. So let's substitute that first equation into the second. So 5, and then the first equation is 3x minus 17. So let's distribute and solve for x. So negative 3x minus 13 is equal to 15x minus 85. Now combining like terms, I would add the 85 to the left, and then add the 3 to the right, and I solve x to be 4. So once I get the x, value, I'm going to substitute this x value back into one of the equations to solve for my y, and I substitute it into my first equation. So y equals 3x minus 17. So y equals 3 times 4 minus 17. So 12 minus 17 is negative 5. And my solution is for negative 5. And that completes number 4. Now moving on to number 5. Here we have a supply and demand equation. So suppose the supply and demand for posters of 2013 Super Bowl champions for a particular week are given by the following equations. Your supply equation and your demand equation is given. So for letter A, find the supply and demand to the nearest unit if the posters are priced at $6. So notice our price is our y value. So let's substitute the $6 into our y value, which is our P for the supply. So P equals 1.6 Q plus 5.2. So we're substituting the 6 into the P. 6 equals 1.6 Q plus 5.2. And again, combining like terms, you subtract the 5.2 and divide by 1.6. And we calculated that to be 0.5. And again, our quantity is in thousands. So because our quantity is in thousands, we have to multiply by 1,000. Therefore, our quantity is 500 posters. So we have 500 posters when the price is $6. Let's do the same here for letter B. So here you want to find the supply. We're not done with letter A. Let's complete the problem. So find the supply and demand. So this was the supply. Let's do the demand. So P equals negative 2.4 Q plus 18. So we're going to solve again for Q like we did in the supply equation. So 6 is equal to negative 2.4 Q plus 18. And again, combining like terms, we solved our quantity to be 5. And multiplying that by 1,000, we have our quantity to be equal to 5,000 posters. So this is our demand, and this is our supply. So if the price is $6, the supply will be 500 posters, and the demand will be 5,000 posters. So now we can move on to letter B. Find the supply and demand to the nearest unit if the posters are priced at $10. So now we're going to do the same as we did for A, but we're going to substitute 10 into our P. So we have the supply is P equals 1.6 Q plus 5.2. So 10 equals 1.6 Q plus 5.2. Again, combining like terms, you subtract 5.2, divide by 1.6, and we calculated Q to be 3 times 1,000 is equal to 3,000. Now for the demand is P equals negative 2.4 Q plus 18. So again, substituting 10 into the P and solving for Q. Combining like terms, we have the quantity to be equal to 3.333. Again, multiplying that by 1,000, we have the quantity to be 3,333 posters. So this is the supply. So if the price is $10, the supply will be 3,000 posters, and the demand will be 3,333 posters. In letter C, find the equilibrium price and quantity. So the equilibrium price and quantity is to set the two equations equal and solve for both letters, Q and P. So let's get the two equations. Our supply is 1.6 Q plus 5.2 is equal to negative 2.4Q plus 18. So here we have to combine like terms, combining the 5.2 and the 18 and the Q's. And we calculated 4Q is equal to 12.8. Dividing by 4, we got the quantity to be 3.2. Now substituting this quantity into either one of the equations, I'm going to substitute it into the supply equation. So P is equal to 1.6Q plus 5.2. So I'm going to substitute that 3.2 into that equation to calculate the price. So I have 1.6 times 3.2 plus 5.2 is $10.32. So therefore the equilibrium price is $10.32 when the supply and the demand are both at 3,200 posters. And this is your equilibrium point. Moving on to number 6. We have another supply and demand problem. So here at $1.40, we have at $1.40 per pound, we have the supply of tobacco to be 1,075 pounds and the demand to be 580 pounds. When the price falls to $1.20 per pound, the supply decreases to 575 pounds and the demand increases to 980. So assume that the supply and demand equations are linear. Find the equation. So the first step we are going to do is to determine the points. So here the point is the supply is 1,075 at $1.40, I'm sorry. So again, remember our quantity is our X and our price is our Y. And then to find the other point for the supply, when the price is $1.20, the supply decreases to 575. So we have 575 at $1.20, and this is our supply points. And then once we have the points, we have to find the slope. And again, the slope is the change in Y over the change in X. So we have Y1, 1.4 minus Y2 over X1 minus X2, and we calculated that to be 0.2 over 500, which is equal to 0.0004. And then once we have the slope, we can find our y-intercept. So let's use our point slope form. And that is y minus y1 equals to m times x minus x1. Again, our y is p, and our x is our q. So we have y minus y1, and our y1 is the p1, which is 1.4, is equal to our slope, 0.0004, times x minus our x1, which is our first point, and that is, the quantity is 1,075. So now we're going to distribute and solve for p. So once we distribute, combine like terms, we have our p, which is also equal to our y at 0.0004 q plus 0.97. And that is your supply equation. Now you are going to do the same for your demand equation. So now determining the points for the demand. So now let's look at the demand equation. The demand is 580 when the price is $1.40. So that is going to be our first point. So when the price is $1.40, the demand is 580. So 580, comma 1.4. And then when the price is $1.20, the demand increases to $9.80. So $9.80 at $1.20. And let's find the slope. So again, the slope is y1 minus y2 over x1 minus x2. So the first y value, 1.4, is y1 minus y2 over x1 minus x2. And calculating that, we have 1.4 minus 1.2 is 0.2 over negative 400, which is negative 0.0005. Now using one of the points to solve my equation, so y minus y1 equals m times x minus x1, again using a point slope form. So I'm going to use my first point, so y minus 1.4 equals our slope, which we just calculated, negative 0.0005 times x minus x1, and that is 580 is my x1. So now distributing and combining like terms, I calculate my equation to be y equals negative 0.0005 q plus 1.69. Again, you could use y or p. Let's just make it consistent. P equals negative 0.0005 q plus 1.69. And the last part is to find the equilibrium price and quantity, and that is to set our supply and demand equations equal. So we have our supply equation as 0.0004 q plus 0.97 is equal to our demand, negative 0.0005 q plus 1.69. And again, we're going to combine like terms. You can subtract the 9.7, or you can subtract the 1.69 and combine the q's. Once we do that, we have our quantity to be equal to 800. So once we find our quantity, we substitute that 800 either into the supply or demand equation, and I'm going to substitute it into the supply equation and solve for my price. So I have P equals 0.0004 times 800 plus 0.97. Again, multiplying that and adding to 0.97, I have a price of $1.29. So therefore, the equilibrium price is $1.29 when the supply and demand are both 800 pounds of tobacco. And that completes Chapter 2, Section 1.